All right, very good morning. Welcome to part 4 of our topic of magnetism. Today we'll talk about magnetic field and its magnetic field lines itself and how to draw. Okay, so let's recall what is a magnetic field. A magnetic field is a region surrounding a magnet in which a body of a magnetic material will experience a magnetic force. Okay, so we know that a magnetic field is invincible. You'll not be able to see this field. Same for your gravitational field, same for your electric field. It is just a mathematical concept for us to have a better understanding of it, to be able to visualize. Is it there? Yes. Is it really like a field where there are lines and all? It may not be, but it is just to help us be able to visualize and understand how it actually works. So how do we know how the shape of this magnetic field look like around a magnet? So what we want to do, we need a compass in this case. So we need a small plotting compass to plot the field lines around the magnet. The figure on the right shows how this can be done. So what we want to do, step number 1, we want to be able to plot out the field lines. We all know that once we have a magnet itself, this magnet will be able to trace out, it will be able to point north. This magnet always want to point north, and it is called a north-seeking pole. So step 1, what we do is we place the bar magnet on a piece of paper. Then we place the compass near the north pole first. So we start off with near the north pole of the bar magnet. We mark the endpoints of the compass needle on the paper. We mark it such that it is X and Y. So we start here, this will be X, this will be Y. Move the compass so that the compass needle coincides with one of the mark points. So now we move it to the next point here, the compass, we move it up, so such that it coordinates with Y. Okay. Then we mark a third point at the other end of this compass with a Z. So from there, we slowly progress up. Then we move it up again. Continue doing this until it reaches the South Pole. So we join again. Next one, X, Y, Z. Maybe we start off with A again. Then A, we join to B. So we keep joining them. Once we are done, what we need to do is to join the compass needle. Join this compass needle all together. And we will get one of the magnetic field lines. So the direction will be in this direction. Okay, and then you repeat the process for every other single area around it, then you'll be able to see the field lines around the magnet. Okay, yes. So for the magnetic field pattern of a bar magnet, if we have a bar magnet, the field lines around it are as shown on the figure on the left here. Some things to take note. Number 1, the arrows of the field line always go from north to south. Let's take a look. You see here, north, the field lines will point the direction towards the south. Make sure you must have your arrow. Okay, so what we want to do when we draw, so be very careful. As we are nearer towards the pole, can you see that this region here and this region here, I draw two rectangles of the same size. The rectangle inside here has two lines inside, whereas the rectangle here only has one line. What does it mean? It simply means that if the lines are closer together, and where it is nearer towards the pole, as you can see here also, when there are more lines, the magnetic field is stronger. When there are less lines, the magnetic field is weaker. So when we draw the lines itself, we must remember to indicate the lesser the more lines they are together, the stronger the area of magnetic field it must be. Next, the field lines must not cross each other. So these are the few principles of drawing the electric field lines. So let's draw for the magnetic field lines, or let's take a look here. Magnetic field lines always from north to south. We use a solid line, draw across, north to south. Similarly, we'll repeat. This is closer, symmetrical for the other side. As we can see, as we go further away, this is further away. As we are further away, this should be further away. So remember, the field lines that are closer means it's stronger, field lines that are further away must be weaker. Then we join up for the rest of the magnet around it. Okay, make sure their direction is correct. It's always going towards the south. Okay, and make sure that it's symmetrical top and bottom. What happens if there are two north poles now? So if there are two north poles, what will happen is they will repel. So field lines must go in the following direction. Similarly, the more lines there are, the stronger the field. And then you want to repeat it to the other side such that it is symmetrical. Okay, so this is for the magnetic field patterns for two north poles. If you notice that in the middle here, this X point here, there is no field lines. Why? Because this is called a neutral point. Both magnetic fields from both magnets cancel out each other completely at this point. So you place an object in this point itself, it will not experience a magnetic force because there's no magnetic field there. So if you place an iron nail at X, what will it be attracted to either magnet? No, it will not be attracted to either magnet. Why? Because the magnetic field from both magnets cancel out at the neutral point X. So what is the use of this itself? We know the field lines. What can we use it for? Some equipment itself needs to be protected from magnetic fields. Otherwise, you will be able to you will destroy it. So one way of protecting this mechanism is to use magnetic shielding. So what do we mean? We have a magnet here, north and south. Okay, they have a few lines that should go straight by right. But what happens here if they place a iron container, a hollow iron container here? This is made of iron. What happens is this iron container will concentrate all the field lines through it. So the field lines supposed to go straight, but it did not. How did it move instead? It flows into the iron core before it gets out. So it's able to concentrate all of them and make sure that the lines do not cross. They are able to concentrate all of it around the iron. Why? Because iron itself is a good magnetic material. It is able to be magnetized very easily. So it will want to channel all of these magnetic field lines through it. What does it mean? It means that in the middle point, there is this point X again, where there is no magnetic field. So if you need any objects to be protected from the magnetic field itself, you can place it at X, and it will be protected from the magnetic field. Okay? Alright, so that will end for our magnetic field pattern. I think we need to do a bit of drawing, so let's begin.